Okay, Rich, are you good to go?
Good.
Okay, let me stop sharing here.
Turn the music off.
Yep.
Okay. Welcome, everyone, to the CAMP 2021 Virtual Symposium. It's really terrific to have so many of you here and join us today. I especially want to give a shout out to all the students. I know that right now you're doing lots of different things. You're applying to graduate schools, you're interviewing at graduate schools, you're taking midterms, and I appreciate your taking the time over this long weekend to give your presentations. I'd also like to give a shout out to our nearly 70 faculty judges who have also volunteered their time this weekend. In particular, I want to call out a few people. First is I want to go back in time. And I noticed that Marjorie DiMartino is here. And, you know, for many years, she was the camp project director and, you know, was always responsible for somehow pulling off this amazing face-to-face symposium that we had every year. I don't know how you did it, Marjorie. We're all exhausted just doing this virtually, but it's great to have you join us today. We hope that you're enjoying your retirement. I see this big smile from Crystal Cunningham, who's going to be speaking in a minute. So thank you. And then this year in particular, this would not have been possible without the Herculean efforts of Nii Tran and Lolita Atkins. Nii is at UC Riverside, Lolita is at UC Davis. They are our Camp Symposium co-chairs, and they have pulled this off with a plum. They're just amazing. I don't know how they did it. So thank you for all that you did. In addition, I do want to acknowledge and also appreciate all of the program coordinators at your campus, including Jorge Arroyo from UC Merced, David Artis from UC San Diego, Janet Goins from UCLA, Feather Harris from UCI, Diana Lizarraga from Berkeley, Juliana Ortega from UCSC, and Julie Standish from UCSB. Thank you for all that you do. And of course, to all the faculty directors as well. You make camp what it is. All of you, this is just a fantastic team. It has been my privilege to be involved with this program for over 25 years now. And I'm not the only one. Many of our faculty and project directors have also been involved over that period of time. So thank you for all of that. You'll be getting further instructions at the end of this, but we have a program. And so first part is I'm going to introduce our program officer at NSF, Dr. Michelle Olivia Claville. She has been our program officer, I believe, since 2019. She actually is being borrowed from her position at Hampton University, but she has an interesting background. Her first degree was a bachelor's degree in English. She then went back to school to get a BS degree in chemistry and then a PhD in chemistry from the University of Florida. She then went to work as a senior research and development chemist at Albemarle Corporation in Baton Rouge in Louisiana. And then she went to Southern University, first as an assistant professor, and moved up through the ranks quite impressively and was rewarded like all successful people who become full professor. They made her department chair of that department. She was renowned for her teaching there, and she taught all the organic chemistry sections while she was a professor there. And then I think it was in 2011 went on to her position at Hampton, where she was assistant dean of the School of Science. She has received a number of awards, including a very prestigious NSF Career Award. She has been active as an organic chemist, has mentored many students. We're just delighted to have her as our program officer, and she wants to take a few minutes to speak to you directly. Dr. Claville.
Good afternoon, everyone. Thank you so much for this very kind introduction, Rich. And somebody said, yay, organic chemistry. Woo, woo, woo. And I agree. Thank you so much for the kind introduction and the welcome to participate in this really incredible event. As you've heard, I'm Michelle Claville. I am the program officer that manages this particular activity and the California Lewis Stokes Alliances for Minority Participation. Um, Before I continue with my remarks, I wanted to recognize the other members of the Lewis Stokes Alliances for Minority Participation, or LSAMP team at the National Science Foundation. Um, I want to recognize first and foremost Dr. James Art Hicks, and he is the former team lead for this program at the foundation. He recently retired, and many of you may have interacted with him, and you know that this is a very great man of great stature with shoes that we would only dare try to fill. We congratulate him on his retirement, and for the brief time I got to work with him, a year, I am honored that that I did get that experience. I also recognize Martha James. She is the co-lead, or now the lead, for this particular team at the National Science Foundation. Sandra Romano, who is a rotating program officer like myself, comes from UVI. And we recently have two other program officers who joined us. Sonja Montas Hunter. She comes from, let me not do that because I'm going to mess up somebody else's. And so Sanja, she just joined us. Crystal Smith has also joined us. And then of course, Cynthia Douglas, our program specialist, Al Wilson, some of you may have interacted with him. And Francis Carter Johnson. Together, Al and Francis take care of data, not just for LSAMP, but for the entire Human Resource Development Division. And we are a true team. This team works together to make sure that we serve camp well as all the other alliances and projects that fall within our portfolio. So as I started to say, I'm very thankful for the invitation to provide remarks to all of you. From what I suspect, this may be your very first virtual symposium. And so I understand, having just done another, a similar, not symposium, but actually a PI meeting last week, I understand that this is no small feat. I've planned in-person symposia, conferences, and the like, and it's interesting. Some of the things that we take for granted for that should happen at any symposium. It's very different when you plan a virtual setup, and so I congratulate you for this event, and I also congratulate all of you for being here and being recognized or getting ready to present at this very important event. And so as I thank you for the opportunity to provide remarks, please know that it's an honor I don't take lightly. It's for several reasons, and here are just a few. You could have had your event. You don't have to have me here, and so you didn't have to invite me. And I thank you for the invitation. The second reason that I think of, and they're multiple, I'll only mention a few, I get to witness this amazing camp team in action. I get a bird's eye view of the reason why camp has been around for more than 28 years. I don't know the exact amount, but I know it's more than 28, and it's a phenomenal feat. Camp has supported and continues to support and positively impact students who are talented, filled with promise, and who are destined for greatness. And yet, these same students might have been ignored without camp. And so I get to be a part of this, if even for a few minutes. I am thankful that you allowed me to be here to witness this. I get to interact with your amazing mentors. Before the conference started, the symposium started, I heard the large numbers of students who were participating, and then the mentors who have agreed to support the students, not just because, oh, there's some boost to their research, research, acumen, maybe laboratory or finances or something, but because they are committed to making sure that diverse students broaden participation in science, technology, engineering, and mathematics through the UC system. And so they're committed to you. This is not something that that is as common as one would like. And so for me to be a part of a conference and welcome people like you is something that I am very honored and humbled to be a part of. And then the last thing that I will mention is that I get to go back to NSF and report that CAMP is continuing to demonstrate commitment to the mission of LSM and NSF at large. And so with that, let me recognize also the current PI and co-PIs. And I see that just from the chat, it is very likely I'm going to miss names because I don't know everybody. But I do know Kim Wilcox's name, and I do know Rich Cardillo's name, and I do today I've met Nee Tran and Lolita Adkins. Thank you. Thank you so much for the work you've done. I also recognize your partnering institutions, such as I start with UC Irvine, that was the lead camp that led the Camp Alliance since its beginning in 1991, and I thank you for your commitment and your excellent work in with regard to serving our students. UC Berkeley, UC Davis, UCLA, UC Merced, UC Riverside, UC San Diego, Santa Barbara, UC Santa Cruz. And I hope I did not miss any because I tried to make sure that even with just 1 year of service at the National Science Foundation, that I was intimate about recognizing all of you for your collaborative work, for the good, not just of the students, the individuals, so they can have a pat on the back, not just for the good of your institution, so that you have bragging rights, not just for the good of your state, for California, but I would dare say for the good of the nation, and even to the point of the good of the world. We are living in unprecedented times, and hence the virtual nature of this conference. We are living in unprecedented times when the conversation about diversity is very active and at the forefront of our minds. And so to demonstrate how valuable people who are diverse are and how valuable they are to the fabric of what makes us the United States is something that I applaud you for not just talking about, but for demonstrating. And so with that, I will end my comments here and say, welcome, welcome to this conference. Welcome to another dimension of the world of STEM. Welcome to the rest of your lives, because for some of you, this will be your first time presenting. For some of you, you're veterans at this, but it is still a launching pad into what you will do next. Some of you are not so happy with your research. Some of you are ecstatic and you're ready to, strut your stuff, if you will. But all of you together will do wonderful things. And I, for one, am looking forward to hearing about the great things you've done just because you've been a part of camp. Congratulations on being here and welcome. Have a good day. Thank you.
Thank you, Dr. Claville, for those very kind words and for your continued support of CAMP and the entire LSM program and everything you do in your role at NSF right now. So before we continue, I do want to acknowledge a few more people. First of all, I'm looking out at the gallery and I'm seeing all these beautiful backgrounds, especially the camp backgrounds of 3 different colors, which we have Christian Noble to thank for that at UC Berkeley. So thank you very much, Christian, for that and all the work that you're doing along with Diana at Berkeley. In addition, I do also want to recognize our co-PIs. So Star Lee, who is now at UC Irvine, is an educational researcher and assistant professor there. And then Brandon Brown, who has a bit of a camp history himself, he's an associate professor here at UC Riverside, but was a camp student at UC Irvine. And he is actually living the LSAMP dream, having moved up and is now a professor here at the University of California. So I also wanted to recognize those very important people. So now we get to move on to our keynote, and I'm delighted to introduce to you Dr. Crystal Cunningham. Crystal, are you used to that title yet?
I'm getting used to it more and more.
We're good. So we're really proud of you, Crystal, and really pleased that you decided to accept our invitation. Crystal got her bachelor's degree in material science and engineering at our newest campus and our newest member of the Alliance, UC Merced, and got her PhD as a bridge to the doctorate student at UCLA, and she got her degree just last year. She is now a discipline scientist at Raytheon in Los Angeles. But a couple of things that impressed me about Crystal, which is typical of a lot of camp students anyway, LSAM students in general, she goes far beyond just, being focused on science. She also has a terrific track record in service. And while she was at UC Merced, she was involved in a couple of things through the Black Society of Engineers. She was a member of something called Science for Tomorrow Educational Partnership, which was STEP. And there she gave countless hours in community service as a mentor and a tutor to young children interested in STEM fields. She then was in an outreach effort through the National Society of Black Engineers, also while she was at Merced. Technical Outreach Help Group was called Torch. She actually chaired that particular committee. She developed a mentorship program with local boys and girls clubs there. She helped science fairs there. So again, there's a number of things that Crystal has done in this short period of time, but she's doing exactly what we see many of our students do. They just don't accept the gift of being in camp, right? They also give back. And by doing that, you're continuing the legacy, and you're just at the beginning of your career, and you're establishing, I'm sure, what will be a very impressive legacy. So we're looking forward to following you, but even more importantly, we're looking forward to what you have to say to us during your keynote. So please welcome Dr. Crystal Cunningham.
Thank you, Richard. I'll go ahead and share my screen. So please let me know if you're able to see it. Oh, there is now privacy rules.
You're not able to share?
Yeah, it says I have to click out and come back in. So sorry about that. Give me like 30 seconds.
Okay. Okay.
There we go. And then I'll share my screen.
Perfect.
Are you able to see that?
Yes.
Okay, perfect. So again, thank you so much for inviting me to be the keynote speaker. I was really just humbled by the opportunity because camp truly, truly, truly started my my journey into research, and really has set the stage for all the things that I'm doing now. So I kind of go through what that journey has been like and the impact that Camp LSAM Bridges to Doctorate, the part that they've all played in my journey. So I grew up in Jamaica. I moved to the US in 11th grade, so some years ago. And at the time, I didn't know what SATs were, the process for applying for college. And so I went from chilling on the beach and enjoying the cool breezes of Jamaica to all of a sudden filling out SAT applications. And everything kind of worked out. I started UC Merced as a materials science and engineering major. I really love airplanes, space. And so I wanted to do aerospace engineering, but at the time, Merced did not have that major. In the top left, right corner, and let me know, I'm scrolling my mouse if you can see, it's a picture on graduation day of my undergraduate advisor, Dr. Lillian Davila, and I. And she was the one who actually introduced me to camp and told me what camp was, because at the time I had no idea. And through that, I was able to go on and complete my PhD at UC Merced. But as I kind of talk about my journey and what that process has been like for me, I would like to leave you with some words to kind of keep in the back of your mind as I talk through them. And they're mentorship, passion, network, experience, research, the challenges that we all face, and sometimes the risks that we have to take, and how I've grown through all of that. So how did it all get started? At my time at UC Merced, I was able to do a summer research program in 2012 through the PG&E summer program. And at the time, my undergraduate advisor, Dr. Lillian Davila, was studying carbon nanotubes with her. And she told me about camp and this awesome program that was at Merced. And so I met up with the coordinator there who told me about the symposium that's held in Irvine. So just to give you some sort of perspective, I graduated the fall of 2013. I walked in May, but officially graduated the fall of 2013. So it was already kind of at the end of my undergraduate career when I found out about camp. And I was just starting to really understand research and whether or not I liked it. So upon arriving at camp, I presented my poster and met a lot of different people and just saw the breadth of work, met professors, and I was really impressed. I really liked just the diversity of topics that were being discussed there, and it fueled my passion to further my ability to do research. And through that, I found that a way to do that was by taking on a PhD program. But one of the key things that I took away from my experience at camp back at UC Irvine in 2013 was when I met Dr. Juan Francisco Lara. And you can see the picture of him and I here. After giving my presentation, he took this picture because he wanted to have it in case I won some Nobel Prize in the future. Maybe it's not too late, we don't know yet. But he sent me this email saying, congratulations, I look forward to your career. If your family asks, how did it go? Don't say fine, but read or show them my email so they can learn how impressed I was with your presentation. You can quote me. And this really stood out to me, not only because camp was such a pillar of research and network, but the fact that even though I presented, it was really my first time presenting research outside of UC Merced, I met someone who saw something beyond what I was seeing in myself at the time, and then took it a step further to send in my family, my mom, this email. She still reads this email to this day. But it really connected for me the fact that, being someone who's going to college for the first time and then studying engineering for the first time, and sometimes finding it difficult to communicate what I'm doing with my family, and just kind of saying, you may not know the science that she's doing, but here she's doing something well, just meant the world to me. And he actually helped me transition from UC Merced to UCLA. So I'm forever, happy and glad that CAM really started that experience for me. At the time, the partner UC was UCLA, and I was told if I applied to UCLA, I can be qualified for the Bridges to Doctorate program. I had other plans though. Research wasn't in my future, wasn't something I thought about. And I had already planned to study abroad in Italy for about 3 months. And while I was there thinking about all my experiences, camp was just, it kept coming back to me. And so I decided, you know what, I wasn't fluent in Italian at the time, but I went and took my GRE in Rome and decided to apply to UCLA. Being that I love space and I was in Italy, it was only right that I wanted to combine the two, to find a way to study art and science and still make an impact within the scientific community. And luckily for me, I met Dr. Ioana Kukuli, who became my PhD advisor. Her lab did exactly that, studied science and art. So how did camp impact me as a graduate student, and being able to stay a part of not only camp, but LSAMP and being a Bridges to Doctorate fellow? Upon my acceptance to UCLA, I met Dr. Diana Zordia, who I also owe a great deal to her, and she's really, truly an awesome person. And she welcomed me as one of the newest members to Bridges to Doctorate. And I continued to participate in LSAMP. Here in the left-hand corner was my first LSAMP conference that I went to as a PhD student. And it really helped because I got to discuss my research outside of UCLA in that world, as well as saw what other people were doing. And be involved in LSAM. Camp was such a major part of my life that it really meant a lot for me to keep going to these conferences. But LSAM and being a part of Bridges to Doctorate also allowed me to have flexibility. Apart from the community, the network that I formed, they paid for some of my PhD. So I was able to have the flexibility to take on other fellowship opportunities outside of UCLA. And being that my research studied ancient materials, I did a fellowship at the Metropolitan Museum of Art for an entire year, working on the collection there, along with the collection in cross collaboration in London. And because of the research, the work that I was doing, I told them about LSAMP, and they were very supportive of me going to that conference. I was later invited to give that talk in Spain, at a conference in Spain. And to touch a little bit about what Richard said in regards to my passion for community service, is that I really, 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 no matter where I go, what I do, I always feel like I need to give back. And so I asked the Met if we can host a science fair there, and we were able to bring in students from various communities and teach them about science and arts and how you can combine the two. And Voices of America was really excited about this program. And in fact, they do this program yearly now. So I kind of switched gear a little bit and talk about my research. I, of course, will not go super deep into it because we don't have all that time. But I studied ancient archaeological materials, specifically cobalt blue. It was of importance because of the type of material it is. It's a spinel ceramic, and we're interested in it because it only lasted for about 200 years, then it disappeared, and no one really had an idea of how exactly the Egyptians made it. Fast forward to today, we're trying to use spinels to replace glass products that we need higher strength for. So if you can think about a fighter jet, and the dome that covers that pilot is currently made out of sapphire. We want to switch to spinel because it's much cheaper, but give you similar properties. So my research had about 3 different sections. One, I studied the ancient material and how it was made. I tried to recreate that, then pulled that properties into modeling it to see how will this material survive space? How will it survive even commercial uses? So overall, my research, the point of it was to take what we know from ancient materials, ancient technology, and use that to inspire and create technologies of the future. But how's it going? How did I transition from all of that into where I am now? I really loved what I was doing. I really love art. I really love science, and the fact that I was able to merge that. But there was a point in time where I said, okay, Crystal, how do you make this marketable to the aerospace industry? And luckily for me, when I went in my interview for Raytheon, they said to me, well, you work on ancient materials that last for 200 years. Can you make us something that lasts in space for about the same time? And I thought in that moment how cool that was, that I got to, it finally connected. All along my PhD, I figured, okay, at some point I will be able to connect them both. But in that moment, it connected for me. And of course, I accepted the job. I'm at Raytheon Technologies now as a senior multidiscipline engineer in the materials and processes department. I work on both space and airborne programs, doing materials analysis and development. And about an hour ago, I just accepted my award of being the Black Engineer of the Year, Modern Day Technology Leader for Raytheon Technologies. And all of this, looking back at as where I am, the fact that I was able to get this BEA award, I've been with Raytheon a little bit over a year now, all started with camp. It started at the very same place that you are all at now, though it's virtually. And camp has forever changed my life and will continue to do so as I step into these various opportunities and that I've been given. So with that, I want to leave you with kind of 6 key things that I take throughout my career, that I take throughout my life. Some of them might resonate with you more than others, but I start with the first one, Wilikaba Witaloa. It's a saying we say in Jamaica to say, you're small, but you're powerful. And I know it sounds cliche, but I can't tell you the amount of times I saw big mountains in front of me and I'm like, there's no way I'm going to get over it, but somehow I've made it. And then make the most of every opportunity. As you're here at camp, just really surrounded, though virtually, by all the awesomeness that camp has to offer. The people that are here, they want to see you succeed, and they want you to become the best scientist, best engineer that you can possibly be. Make the most of that opportunity and every other opportunity that's to come. And it takes a village. It takes a village, and building your network kind of go hand in hand. I can't think of a time in my life that I've done something just on my own. It has always taken me a community. And to give you a point of reference, my undergraduate advisor and her husband flew to LA just for my graduation for my PhD. And that is the power of your network. And you deserve a seat at the table. There were plenty of times that I've gone through where my seat at the table has been questioned, my voice has been questioned, and you kind of have to think about all the hard work that you're doing, the research you're presenting, all the things that you're doing now. You've put in work to do that, so you deserve a seat at the table. And lastly, I leave you with a quote from Brene Brown on vulnerability. Vulnerability is not winning or losing. It's having the courage to show up and be seen when we have no control over the outcome. So here you are at camp. Some of you are presenting your work for the first time or presented several times before that. But the fact that you're here, the fact that you're showing up and being present, you're stepping out of that vulnerability and open up yourself to opportunities that today and every day onwards from here may bring to you. So with that, I'll end my keynote. Okay. I stopped sharing.
Okay.
So back to you.
Thank you very much, Dr. Carningham, for those inspirational words. I noticed in the chat that Dr. Claville is also from Jamaica. And so she said she totally gets it. So thank you very much. I'm wondering, we have a couple of minutes. Maybe would you perhaps take some questions? If anyone has questions? Would anybody like to ask a question?
Oh, and thank you all for your comments, by the way. I'm just now reading the chat.
Well, I'll ask you a question.
Okay.
What, this may be a hard one to answer, but what was perhaps the single biggest challenge that you had to overcome, either as a child or maybe when you were at Merced or at UCLA?
I say the single best, the single challenge that stood out to me really was after I went to camp. There was a moment of realization that said, okay, you want to do your PhD, you're nowhere prepared to do your PhD. And trying to pull together myself in trying to get prepared as much as possible before that deadline in the fall.
Mhm.
And trying to do that while you're in Italy and not knowing the language and trying to take your SATs in Italian, that was single-handedly one of the greatest challenges I faced.
Yeah, okay, that's great. Anybody else? Oh, okay. So Matthias cannot unmute himself, but asks, after all the experiences you've had so far, do you still get nervous? How is it like to prepare this presentation?
I do. This is personal for me, and so I wanted to really be authentic and true to my journey and the challenges that I went through. So I think that helped to present. When you're telling your story, I think it's a lot easier to prepare for the presentation, but I still get nervous.
Yeah, great. Diana from Berkeley asks, can you please share how important your camp peers were for you?
Very important. One of the greatest lessons I learned from my camp peers is that I'm not alone in a lot of my experiences. Like, I have a group of people that I'm going through these experiences with, and even being a Bridges to Doctor fellow, when we're going through our PhD, we actually had sessions with our other fellows where we would just hang out and watch movies because we all needed a break from our everyday graduate school life. So it was very important because they're all going through similar experiences as you are.
Great. Well, with that, again, let's see. Oh, okay. Well, this will be the last question though, so we can move on. Okay. It is, Dale writes, I am also impressed by your experience at Raytheon, an example of employment opportunities beyond academia. Would you share a bit about which opportunities you explored and why Raytheon stood out?
Okay. I explored aerospace because that's what I'm passionate about. That's what I like. And Raytheon stood out to me because of the wonderful work that they were doing with space and the opportunities they had there to kind of excel within material science, but for me to also learn, because I know for sure I didn't have all the tools in my box that I needed to become the engineer I wanted to be. And I think Raytheon really stood out to me that they can teach me that. So
great.
Yeah.
I'm going to ask one more question because I think this one is very important. This pandemic has challenged us all in a variety of ways. What would you say to a camp scholar who is feeling discouraged at this very moment?
Yes. So the pandemic has created several challenges because everything is virtual and it's really hard to connect personally, but I would approach it to after you go through the camp process, if there's someone that you've met, even if you've met them virtually, follow up, connect with them and say, see if they have time to perhaps set up a Zoom call and stay in touch. It's always been important. It was important pre-pandemic, and it's even more so now because we don't have that in person, we click right away, or that level of, oh, I know you, I see you, and I want to connect with you. Now you kind of have to make a little bit more step forward to say, I do want to connect with you post this conference.
Well, you are obviously brilliant You have an extremely bright future ahead of you. And of course, you are an alumna, which means you never are going to get away from this. You do understand. And I don't think you want to.
No.
And, you know, the other thing is I am just so impressed. You have acquired already so much wisdom and you are incredibly articulate and giving. And we really appreciate your sharing those words with us today. Thank you very much.
Thank you all for having me.
Okay, now at this point, I'm going to turn this over to our amazing co-chairs, Nee Tran again from UC Riverside and Lolita Atkins, who will talk about our student presentations coming up. Nee and Lolita.
Well, hello, everyone. Thank you so much for joining us. I am Lolita Atkins. I am the program manager at the Undergraduate Research Center at UC Davis. And I have the pleasure of working with amazing camp students, as well as other students in research programs, the MERPS program and the IISH program. And it is the highlight really for me, just to be able to see the hard work that they've done. And in a few moments, you'll get a chance to witness some of that. But at that, I will turn it over to my colleague, Nee Tran.
Thank you, Lolita. So my name is Nee Tran, and I am the camp coordinator at UC Riverside, as well as the statewide coordinator, overseeing all of our lovely colleagues at every single UC. It's been my pleasure working with absolutely everybody across our campuses and celebrate the diversity that we have. It's been extremely amazing, not just meeting staff, but all the students too. Both Lolita and myself have had the opportunity to speak with our next set of guests, and that is actually going to be our student presenters. So as coordinators, when we got together planning this symposium, one of the things that we wanted to highlight were the students, since they are the actual stars of our entire program, our reason and our motivation for putting this entire event together. And so Lolita and myself had met with every single student. We wanted to have one representative from each UC kind of give a little bit of an introduction, not only to their research, but also about themselves. So you will get the opportunity to see some of these students and hear from them, hear their personal stories. We asked them to introduce not only themselves, but what camp means to them and how has it impacted them professionally and academically. And lastly, they'll also give you a little bit of a teaser of their research. So we wanted them to showcase their research, but not too much, because we ultimately want to direct you to see their entire presentations. As you can imagine, we have a lot of presentations already uploaded onto the GoReact system. And at the very end, Lolita will go over some additional details for all of our guests. If you haven't already signed up and started checking out a lot of these presentations, they have been amazing. So without further ado, I am going to share my screen in a second, and we will be bringing on our student presenters. And they will be the ones who, again, they put together some great slides, and we're gonna have the next few minutes just showcasing them. So again, thank you very much, everyone, for showing up.
Hello, everyone. My name is Raisa Mathenge. I am a fourth-year undergraduate student, and my major is in microbiology, immunology, and molecular genetics, and my desired career path is to be a physician scientist in the future. So a little bit about me. I'm from Rancho Cucamonga, California in the San Bernardino area, and I love to practice yoga, bake and cook in my free time. When I'm not doing that, I like to spend a lot of time with my family and my friends. I'm obsessed with anything Disney related or anything Universal Studios related, especially related to DreamWorks animation. And I also love to travel. So the top picture is actually a picture of me and my friend Isabel when we went to Ecuador the first time. I highly recommend going to Ecuador. It is a great place to visit. So a little bit about my journey into research. I first got involved in research in the summer of 2018 when I applied to the Biomedical Science Enrichment Program, otherwise known as BICEP. This program not only introduced me to what a researcher's life was like on a day-to-day basis, but it also provided me examples of the different avenues that I could take as a researcher with a PhD. It introduced me to the MD PhD route, and it also provided me with the opportunity to get into the lab that I am currently working in now as an undergraduate student researcher. In 2019, I applied to the CARE Science, Engineering, and Mathematics program, where I was also funded by CAMP for the very first time. And then in 2020, I applied to be part of the CAMP Scholars program, which is where I am now, here speaking in front of you guys today. So CAMP's influence on me has been absolutely tremendous over the years. It has provided me with a lot of academic and personal development in terms of a lending library in which they provided us with like MCAT and GRE prep, and then also professionally where there were workshops that were held that helped us edit and write personal statements, conducting informational interviews, and putting together poster presentations for conferences and allowing us to network with different students and faculty from around the whole camp program. And also one-on-one advising with a camp mentor. I found that really extremely valuable because it helped us construct a direct path in terms of what research path we actually wanted to go down in the future. So yes, like I said, it has allowed me to develop my academic and professional skills as a whole. So in terms of my research primarily focuses on the differential inductions of antiviral genes from type 1 and type 3 interferons based on a transcription factor called ISGF3. And just to give a brief overview about interferons, specifically type 1 and type 3 interferons, are involved in inducing an antiviral response. However, type 1 interferons are only involved in inducing an inflammatory response. So based on these two different responses from these two different interferons, we hypothesized that type 1 and type 3 interferons induce stimulus-specific gene expression responses. And so if you want to check out my presentation on GoReact, the title of it is Type 1 and Type 3 interferons induce different genes in amyloid-12 lung epithelial cells. And as for acknowledgements, I would love to thank my PI, Dr. Alexander Hoffman, and my research mentor, Dr. Katera Wilder from the Synlink Systems Laboratory at UCLA for providing mentorship and advice on this project. And then also my camp mentor, Dr. Janet Joins, for providing me motivation and mentorship to pursue this research path. And thank you for listening.
Hello, can you guys hear me?
Yes, we can.
Okay, thank you. My screen froze on me for a good second, so of course this is exactly how it's going to go. Let me go ahead and start our introduce our next speaker, and thank you very much, Raisa from UCLA. Great presentation. And I will introduce our next speaker, Ms. Diana Lopez. She's from our very own UC Riverside. So Diana, can you please turn on your camera and unmute, and the floor is yours.
Hello, everyone. My name is Diana Lopez. I'm a senior undergraduate student at the University of California, Riverside. My major is chemistry, and my career goal is to obtain a PhD in chemistry. So I have always been working towards this goal, but personal situations prevented me from achieving it a lot sooner. Therefore, it has been a long path to get to where I am now. For context, I graduated high school in 2009. And then decided to get a certificate as a medical assistant to provide for my family. So I got my certificate, I started looking for a job, I got a job. And so this led to me to and for myself to enroll in various community colleges to accommodate my working schedule and to meet the requirements to transfer to the University of California, Riverside. So in 2019, I successfully transferred, and in the spring, I will be graduating with my bachelor's in chemistry, and in the fall, I will be working towards my PhD in chemistry. So I have been blessed with the support of amazing people and programs such as CAMP that have helped me get closer to my goal. As a CAMP member, I have learned about the vast topics that surround STEM research. I have received financial support as an undergraduate researcher. And most importantly, I have met very inspiring and motivating people that supported me and have helped me obtain the tools necessary to reach that career goal. So if we go to the next slide, we will see, so that's a picture of my first research presentation in the summer of 2019. And so my research experience and my involvement with the CAMP program have reassured me that I'm on the right career path. I started undergraduate research under the advisement of Professor Catherine Urich in the chemistry department that summer of 2019. And so in the next slide, you will see some pictures of some of my products. What we do is we take salicylic acid and we make it into a polymer. You may know salicylic acid as the active ingredient in aspirin or the active ingredient in many acne treatments. The advantages of making this salicylic acid-based polymer is that it is biodegradable, biocompatible, and we can control the rate of release of salicylic acid by adjusting the molecular weight of the polymer and by choosing the appropriate linking molecule that connects the polymer chain together. Also, by making the polymer, we can make different types of materials such as films, discs, microspheres, hydrogels, and therefore it has a potential in different types of applications such as in cosmetics or as a delivery vehicle for injectables. Since if we make it into a microsphere, so we can encapsulate other types of molecules. In the next slide, you will see a picture of my research group and my PI. And so with that, I want to say thank you to everyone who has helped me in my journey. And thank you so much for listening. For any questions or information about my research, feel free to visit my PowerPoint titled Synthesis of Salicylic Acid-Based Polyanhydride Esters. Thank you.
All right, thank you very much, Diana. We have our next speaker is from UC Davis. So Ms. Kaya Jackson, can you please turn on your camera, and now you also have the floor. Thank you.
Hi, everyone. My name is Kaya Jackson. I'm from California, and I'm at UC Davis Sciences. I'm also an undergraduate research assistant in the True Lab at UC Davis. But a little bit more about me. Could you go to the next slide, please? A little bit more about me is that when I'm not working or studying, you can find me spending a lot of time with my family and my friends, drawing, playing sports with my twin sister Kyla, and enjoying the outdoors. I credit a lot of who I am today to my family and my friends, to my cultural background, my African American and Filipino backgrounds, and to all of my mentors at UC Davis, for which I'm extremely grateful to have. Being a part of the CAMP program at UC Davis has not only allowed me to be a part of a supportive community of researchers, but it has also allowed me to be more confident as a scientist, as well as having more options than I never had prior to joining. Do you mind going to the next slide? As for my research with the True Lab, I will be briefly introducing my project, which focuses on how site-specific phosphorylation of clock proteins affects circadian rhythmicity. So have you wondered why, when you wake up early in the morning, you tend to get tired and go to bed early, or why you tend to get hungry around the same time during the day? Well, circadian rhythms help us understand these situations. Next slide, please. Circadian rhythms refer to an organism's internal clock that oscillates over a 24-hour period. Rhythms in animal physiology and behavior depend on the synchronization of two elements: external environmental time cues with an organism's internal molecular oscillator. For example, as you may know, sunlight affects our sleep and wake cycles, but it's also influential on a molecular level, as particular proteins in the oscillator depend on light to function. With this in mind, the desynchronization of clock inputs in the molecular oscillator can be reflected in the rhythmic expression of genes, which in turn affects our physiology and behavior. It can be seen in our sleep and wake cycles, our emotional responses, as well as pathogenesis. Next slide, please. We have circadian rhythms because of circadian proteins, such as a protein clock that works as a biochemical timer. Clock protein has a 24-hour cycle of time of day specific function, and it is a key component within the circadian oscillator. Its role as a main transcription factor helps drive rhythmic gene expression, but notably, clock changes conformation because of an event called phosphorylation. This involves the addition of a negatively charged phosphate molecule to the surface of proteins, changing its shape. So you can essentially think of this time of day specific phosphorylation as an on and off switch or a dial for protein activity. And although phosphorylation has been established to play a central role in regulating protein activity, the mechanisms by which phosphorylation regulates clock is still unknown. Next slide, please. Therefore, the goal of this project asks, if we manipulate key phosphorylation sites, will clock function as a 24-hour timer? And previous research from our lab led us to hypothesize that phosphorylation at serine 13 residue by the kinase casein kinase 1 alpha should reduce the activity of clock by removing clock from circadian gene promoters. In all, we hope the results of this project will not only provide a better understanding for how phosphorylation at specific sites affects clock function, but how it regulates circadian rhythms. And if you would like to hear a little bit more about my project, you can also find my video on GoReact under Biological and Life Sciences. It's titled Site-Specific Phosphorylation of Clock Protein Affects Circadian Rhythmicity. And lastly, I would like to say thank you to, next slide, please. I would like to say thank you to the Chu Lab at UC Davis, to my PI, Dr. Joanna Chu, and graduate supervisor Yao Kai for all their help and for allowing me to be part of this research. I'd also like to thank Lolita Adkins and Dr. Franz, who lead the CAMP program at UC Davis. I'm extremely thankful for all of their help. I'm also grateful to be part of the CAMP program and the Research Scholars program in insect biology at Davis. And thank you all so much.
Okay, thank you very much, Kaya. Great presentation. Now we have our next representative from UC Santa Barbara, Mr. Giovanni Coda.
Hello, everyone. My name is Jota, and I am a third-year geography major with emphasis in GIS, Los Angeles, California. Next slide, please. All right. Currently, my goal is to go to graduate school to work towards becoming a GIS scientist. Originally, my goal was to graduate out of UCSB with a communications major as fast as I can, without really putting much thought into what I actually wanted to do as a career. This is what camp did for me. They introduced me to the idea of that I can do research as a career. Coming from an underrepresented neighborhood, the idea that I can become a researcher was never really instilled upon me. I come from LAUSD, one of the largest school districts in the US. We do not have many resources available to us. When I arrived at UCSB, I immediately felt out of place because I felt everyone around me was ahead of me because they had more opportunities than me. To come into UCSB with little regard of doing research or what I wanted to do as a career, for camp to give me the support and motivation I needed to solidify my new dream of becoming a researcher in STEM means the world to me. Alongside my research mentor, camp has given me the motivation and encouragement I needed to dream further and to never settle. Next slide, please. moving on to research. Right now, I am working on COVID-19 transmission and mobility in water impacted areas. The area of study for this research is LA County in order to look at lake fire, which took place last year during the pandemic. Next slide, please. So we care. This is important because our movement impacts the spread of COVID-19. As we all know, COVID-19, the pandemic, has drastically changed the way we move and interact with each other. And an example of what I'm doing right now is mapping the mobility trends and COVID-19 cases trends in LA County before, during, and after lake fire in order to map trends of changes in mobility and COVID-19 cases. Next slide, please. So lastly, I would like to thank everyone at Move Laboratory at UCSB, specifically my research mentor, Dr. Sumaya Daraj. Also, I would like to thank Dr. Julie Standish, my camp provider. And thank you.
Thank you very much, Giovanni from UC Santa Barbara. So our next speaker will be from UC San Diego, Ms. Natalia Enriquez. She is a physics with specialization in materials physics major. Natalia, you can take the floor. It is yours.
Thank you, Mr. Tran. Hello, everyone. I'm very happy and honored to be here with you representing UC San Diego. My name is Natalia Enriquez. I'm a senior physics major specializing in materials physics, and I will earn my bachelor's degree this spring. At UCSD, I also serve as VP of an org called Undergraduate Women in Physics, or UWIP, where we do outreach and build community among underrepresented groups and marginalized identities in physics. And lastly, I also do research currently for a group called the Cool Star Lab, where we study brown dwarfs and other low mass stars under the direction of Dr. Adam Bergasser. So a little more about me. I'm a transfer student from the Los Angeles Community College District, and my community college experience was actually very crucial to my academic journey because it really taught me to persevere through the discomfort of learning difficult material. For example, when I took my first physics or calculus classes, I had to retake some classes. I was also working either part-time or full-time throughout. So I spent almost 6 years at CC, but I'm not ashamed of it because I think I developed true grit and stamina academically, and now I'm very focused on my goals. And there were many times that I wanted to give up, and even now sometimes I can't believe that this is my field, but I really love it. And upon transferring to UC San Diego, I thought, okay, I made it, and I was relieved, but I knew I still had plenty of work to do and other goals that I wanted to. And one of those goals was actually to do research in the physics department. So I was a little discouraged when my first year went by and I still hadn't surmised the courage to approach professors about research, and my feelings of imposter syndrome were at their height. Finally, right before spring quarter ended, I found out about camp, and what caught my eye about it was that this program was creating space in STEM, specifically for ethnic minorities like myself, and I already felt welcome. So I did research last summer as a camp scholar, and this program had a very positive impact on my academic outlook, as well as on my professional development. They provided very helpful workshops from financial literacy to GRE prep, but what had the biggest impact on me personally was the constant encouragement from our director and coordinator, Dr. David Artis and Ms. Veronica Behar, and I thank them for all their support. I gained a lot of confidence by the time the program ended, and now I don't doubt whether I'm capable of doing scientific research. I think participating in this program has helped me prepare for my future career goals of being a physicist and a professor. So finally, I'd like to share a little bit about what I worked on. My project was called Using CMB Measurements to Gain More Precise Understanding of Dark Matter Density and Interactions, and was guided by Professor Tong Young Lin and graduate student Jung Sung Lee from the physics department. In this project, I investigated properties of the early universe, specifically looking at the particle physics involved, as well as the cosmic microwave background, or the CMB, and how it can be used to look for dark matter particle interactions. So the CMB is oftentimes called a relic of the Big Bang. It's this electromagnetic radiation, and its existence directly agrees with the Big Bang model for the universe. The CMB has these temperature fluctuations, which we can see as red, yellow, and blue spots, with the red and yellow spots representing hotter clumps and the blue spots colder clumps. However, the CMB itself has a characteristic temperature of 2.7 Kelvin, so it's very cold. So when you look back far enough to the early universe, you have this photon baryon plasma, and photons are particles of light and baryons just mean ordinary matter as opposed to dark matter. And so this plasma fluctuates due to the gravitational influence of dark matter. So the temperature fluctuations imprinted on the CMB reflect those dark matter density fluctuations in this primordial plasma. And this is how the CMB and dark matter are related. Next slide, please. From there, I basically worked on understanding statistical methods that were used to design the experiments that are used for dark matter detection, because we can actually constrain the parameters that we want to measure, such as dark matter density, and obtain an expected uncertainty for these experiments so that they can be optimized. And if you're interested in learning more about this topic, you can find my full presentation under the physical sciences section on GoReact. And lastly, I would just like to thank and acknowledge Dr. Artis and Ms. Behar Wentmore from camp at UCSD for their constant support, my mentors, Dr. Lynn and JT, who showed me how to do research, and lastly, Nitran and Lolita Atkins, who helped us prepare for this symposium as well. Thank you all very much.
All right, thank you very much. Great presentation, Natalia. I'm giving you a virtual round of applause if you can't see me. So on to our next presenter from UC Santa Cruz. We have the lovely Ms. Berenice Lopez. She is a physics major, and if you can turn on your camera and unmute, the floor is now yours.
Thank you. Okay, so are the slides? Okay. Hi everybody, my name is Berenice Martinez Lopez. I'm a fourth year physics undergrad and a camp scholar through the STEM diversity programs at UC Santa Cruz. Next slide, please. Okay, I want to start out this presentation with a little bit of my background. I'm from a little community called City Heights in San Diego. I am the oldest of 3 siblings and the right hand of my mama, which you can see at the right top pictures. Growing up with the treasure of various cultures in a big immigrant community, I was a very active member in the community service. In high school, I was part of Rotaract Club, and entering UCSC, I continued to follow the Rotaract model of service above self, and became an EOP Bridge mentor where I advised first-generation college students. From my passion to build community, I was able to create a club called A Counterspace to empower, advise, and give Black, Indigenous women of color a space to express their intersectionalities and in the physics and astronomy department. You can go to the next slide, please. So I was introduced to research by another woman of color in physics, and she advised me to apply to the STEM diversity programs. That's when I was accepted to camp, and I began my journey into understanding what exactly research was and what does research in physics mean. At the end of my second year, I joined an amazing research group introduced to me by the professor Tesla Geltema, and I started a project in collaboration with DES. DES is the Dark Energy Survey, which is an international collaboration that works to map 5,000 square meters of the southern sky. It surveys hundreds of millions of galaxies and supernovae. One of the main goals is to understand the nature of dark energy and dark matter through observing patterns of cosmic structures. They intend to do this through constraining the equation of dark energy through parameterizing galaxy clusters, which is what my project focuses on. What I do is I calibrate cluster membership as a function of spectroscopic redshift and richness, which is just how many galaxies are within a cluster. So the more galaxies in that cluster, the more rich. What I do is I use each galaxy's spectroscopic redshift to measure peculiar velocities of each galaxy with respect to their central cluster, and do a stacked analysis of their velocity distributions based on specific richness ranges. So there are 5 richness ranges I focus on. Throughout this project, I try to, throughout this project, I try to model the distributions to formulate a membership probability function. And then the end results, what I want to see is fitting each velocity distribution with a Gaussian mixture model and to plot the projection effects. And this research aids in understanding the projection effects caused by wrongfully assigning a galaxy within the line of sight of a cluster as a real member of that cluster. So the investigation of projection effects ultimately allows for a deeper understanding of mass, estimations for galaxy clusters in DES, and dark energy. And then next slide, please. And then lastly, I would like to thank CAMP for funding my research, creating a sense of community by allowing me to be inspired by other peers of color who are out there doing amazing research, and for giving me a sense of confidence to believe that people like me belong in the science community. Being part of CAMP has given me the opportunity to be an active member in research and to continue my research studies in graduate school this fall. I would also like to thank the program advisors, Cincy and Yuli, for being there and always listening to me, being there whenever I have problems, and helping my research career grow, as well as my amazing and brilliant PI for her mentorship, her guidance throughout my journey in research, and just thanking her for motivating me to continue to be a leader for other women in physics and astronomy. So yeah, and that's it.
All right. Thank you very much, Berenice. Great presentation. So now we have our lucky number 7 coming from the University of California, Irvine, Ms. Jennifer Perez, who's an ecology and evolutionary biology major. Jennifer, can you turn on your camera and turn as well as you unmute, and you have the presentation.
Hello. You go to the next slide. So my name is Jennifer Perez, she, her, hers. I am a 4th year majoring in ecology and evolutionary biology, and with a minor in global sustainability at UC Irvine. Next slide. Yeah. So coming into UCI, I initially majored in general biology with the mindset that I want to have a career in a medical setting in some way because I liked biology in high school and I didn't fully realize other paths I could take. But after the first 2 years of college, I realized that it just wasn't for me. And I came to this realization that I do enjoy biology, but more so of the ecology aspects of it. And going in deeper about the plant ecology that comes into restoration and conservation projects, that's what I love to learn about. Next slide. And this realization came from a multitude of ways. One is that I volunteered at the herbarium owned by UCI, and I enjoyed learning about plants. And on this slide is from some specimens from the UCI herbarium, which are California poppies, which are one of my favorites. And one is from 2007 and another is 1986. And I just wanted to plug in on how fascinating some of the plants are preserved so well. And we go to the next slide. Another experience that is more recent is that I was accepted into a course called the UC Natural Reserve System California Ecology and Conservation course. It basically it was in person, it was very safe. It brought in 27 students from all of the various 9 UCs to do field research training within the natural reserves owned by the UCs. And this is a picture from Hastings Natural History Reserve near Berkeley. And you can see at this top right corner, I don't know, that the land got burnt by a wildfire. And I was actually able to do small research projects within them. And it just reaffirmed that I do greatly enjoy learning about ecology. Next slide. And I can't leave out camp in this journey, what I want to do with my life. And this is the building on my campus. Camp really taught me how to use all of these valuable resources that the campus has to offer. And it just really made my transition into and soon out of college easier by telling me all of these experiences that I have experienced. And which has been just absolutely helpful because as a first generation student, it was very hard for me to figure out college in general. And most importantly, camp has taught me that it's okay to be a little afraid, but to make sure that I'm not letting that fear hold me back and to seek out help and assistance when it's there. Then we go to the next page. And now the reason why I'm here. So as a part of my research project, I was able to study the Brazilian pepper trees and invasive species dominating a natural canyon near Irvine called Big Canyon. And this is bad because it causes a dramatic reduction of plant diversity, which includes plants like the native black willow tree as shown here. And it just causes a loss of cover for native animals as well. And when I say native, I particularly mean that that species has been there for a good couple of hundred of years. So when a native plant species, for example, gets disrupted, the whole ecosystem associated with that native gets disrupted as well, and just kind of cascades. And so how these Brazilian pepper trees are doing so well is because within their leaves, their berries, and their roots, they're just exhibiting these chemical defenses that are only absorbed by a certain species of mycorrhizal fungi and are altering them. And mycorrhizal fungi are basically function in a way that fertilize plants naturally, and most plants can't live without them. But not all mycorrhizal fungi are the same. It has been researched that only the native mycorrhizal fungi really help native plants. So when introducing a whole new diversity of mycorrhizal fungi like the pepper trees are doing, the native plants are just not flourishing anymore and they could be like detrimentally impacted. And there's already been efforts to remove these pepper trees and replace them with native plants. Next slide. Next slide. However, what was my train of thought? Sorry. However, the main question that the research I am doing wants to obtain is how much diversity of altered mycorrhizal fungi is still in the soil even after removing those pepper trees. And this is an important question to answer because we need to appropriately mitigate the impacts so that the planting of the new native plants isn't impacted negatively from the get-go. And next slide. And if you want to know more about this research and how it's done, you can watch my Go React video under the environmental sciences. And next slide. And now I would like to thank Dr. Kathleen Tressiter and David, who has given me this opportunity to do research with them, as well as with Neil, who has been working alongside me and has also been such a great help to me. Next slide. I would also like to thank Newport Bay Conservancy and ESA as well, because they're the ones that's actually doing the restoration work in Bay Canyon. Next slide. And I would also, of course, want to thank all of the camp faculty as well. Everyone has truly been so nice and was able to provide me with a lot of assistance in my time at UCI. And I don't think I could ever forget about it. That's all.
All right. Thank you very much, Jennifer. Great presentation. Good shout out to UCI. And now we have our next presenter, lucky number 8, also from UC Berkeley, Mr. Jesus Rios, who's a nuclear engineering major. So Jesus, can you turn on your camera and we will go through your presentation.
I believe my camera's on. Okay, there you go. So hello, hi everyone, thank you for coming out. My name is Jesus Rios and I am studying nuclear engineering and I am a senior. Right here you can see I'm wearing Sombrero de Charro out here close to where I live in the rural area. This is Martinez, California, close to Berkeley. So we'll get to more about this picture later, I guess. So next slide. So I'll go and give a background of where I come from. So I grew up in the city of Bell Gardens, and then I moved to San Angelo for a year and a half. My family, we then came back to the neighboring city, Cudahy, as you can see in the bubble. And that's pretty much where I lived when I went to high school. I ended up just going to the same high school where all my childhood friends were. And as you can see, that was a 16-minute bike ride according to Google, but I'm pretty sure it was much faster than that when I was rushing to class. And then after that, I got into Berkeley and moved to Berkeley for 1 year in the dorms, followed by 3 years in apartment housing. And then interestingly, now I have my own place here in Martinez, California, and I'll get to that right now in our next slide. So a little bit about me. So as some of you know, housing is quite a bit of an expensive thing to deal with at times. And so that really ended up pushing me into having something sustainable. So long I don't sink, I can continue to live into this houseboat for years to come and pay a fraction of a fraction as to what the housing rate goes in the Bay Area. So currently I'm in Martinez, as I stated, and a little bit about my boat. Her name is Trinity, and a lot of puns in that name the more you look into it. But yeah, here are some snapshots of what my environment is like. I'll get to that a little bit more later, but yeah, we'll continue on to the next slide. So I'm gonna give you guys a little bit of a snapshot as to what it is like to be me. I believe we might have skipped a slide. Oh no, sorry, there's just a misorder right there. Yeah, so go ahead and hit play if you can. This is me playing. Just a quick little snapshot of what Cal life is like for me when there's not a pandemic going around. And so going on to the next slide, I'll get a little bit more about Cal life for me. So in Cal, I've learned to make my home away from home in the sense that I have made a community here. Big part of that community is obviously the mariachi, as I've grown up with music. And additionally, I am involved with Hispanic engineers and scientists, and through that organization, I came across Nerds, which I'll talk to more in a bit, but is the umbrella organization that hosts the programs such as CAMP. And additionally, I am also involved in American Nuclear Society because that's relevant to what I'm studying, and the Nuclear Engineering Design Collaborative. And so on the next slide, I will now give my special thanks to the CAMP research, what CAMP has really meant to me. So CAMP and in general, Cal Nerds is definitely what we feel our community as undergrads will call a home away from home. Usually we'll be there studying. It's our safe space. It's our space where we don't have to worry about who is around us because we all look the same. And it's just a bunch of us undergraduate students that sometimes stay there until, yeah, I've been there for like 4 a.m, leaving to go get breakfast. I'm like, well, that's what an all-nighter is like, right? But yeah, so thank you so much, Di, for having a wonderful home for us in UC Berkeley. And in our next slide, I'll now start talking about the research I'm involved with. So my research first started by getting to know my professor via office hours. And then our next slide, I have a picture of my professor and the research group that I first got involved with. So next slide, please. And so if you see right behind me, hopefully my face has become familiar by now. There is a great gentleman. His name is Lee Bernstein. And so he is definitely a person who I would say has planted the seed in giving me the opportunity to really dive into research and really see firsthand what it's like to make innovative research ideas come into a reality. And so in particular, the project that I got involved with is very impactful and can have real change in the world. So just before I move on to the next slide, I would like to say that this is the Nuclear Data Group, not all of it, but more, just specifically the isotope production group. And so this was a picture back in 2019, 2018. And so here at the Nuclear Data Group, we work at the 80-inch cyclotron, which has some very rich history for Lawrence Berkeley National Lab. Specifically, the experiment that I am going to be presenting on is an experiment that was done in one of the caves that the cyclotron produces beams for irradiation of our targets. And that cave particularly is called Cave Zero, and has great shielding in the sense that it shoots the beam straight into a mountain, so it is a very safe place for high neutrons to go to, and I'll get that to a bit. But yeah, on the right picture, you can see what Cave Zero is like inside. So through my research experience, I've actually had the opportunity to go visit Oslo with my research group. So this was the 7th workshop on nuclear level density and gamma strength in Oslo at the University of Oslo, and the dates specified here. And that first top left picture is a picture of everyone who attended that workshop. The following other pictures are pictures of a 2-week course that I took, and this was our weekend outings when we were not taking classes. So in our next slide, I'm going to talk about, I'm going to speed through this one. So this is what I'm currently involved with. I'm actually involved with the bioactinide chemistry group at Berkeley, and it's very well connected into the project that I will be presenting on. So next slide, please. And just paying my respects, post-grads and grad students that are involved in the second group that I'm involved with. And here are the undergrads, and as you can see, I am at the bottom right. And so, I'm gonna have to leave you with the cliffhanger. If you want to really find out more about what I really do, I can promise you it's very interesting stuff. It's stuff that can really treat cancer if done correctly. So my overall research is on the cloud of making nuclear medicine. So special thanks and acknowledgement to CAMP and everyone who is involved in directing this organization. It has really given me the financial stability of that I will be back financially and won't have to worry about providing free labor in my research endeavors. Additionally, there's so many people that I would thank too as well, but also the Department of Energy for funding all the stuff that we do at the cyclotron and at the lab. In our next slide, I'll go ahead and end real quick. I would like to end with this quote. From Marie Curie, we must have perseverance and above all, confidence in ourselves. We must believe that we are gifted for something and that this thing must be attained. So particularly this is heartfelt for me because I have felt like I definitely, like many of us here, have carved out a way that, carved out a pathway in our careers that we really couldn't follow a guideline. So unfortunately, I'm out of time and we'll have to end it at that. But thank you so much for your time.
All right. Thank you very much, Jesus. Very great story. I still love how you are on a boat. And you got to share a little bit of that with us yesterday. So last but not least, we will have our representative from UC Merced. This is the wonderful Mr. Matias Lopez, who's a physics major and also a very, very big character. So Matias, the floor is yours.
Hi, all. My name is Matias Lopez. How are you all doing? So we can start the animation. Thank you. So my presentation, in addition to a little bit about myself, is designing an experiment to measure the momentum of light. So a little bit more about myself before I go into more detail. So I'm a 4th year physics major in my final semester, education minor. And let's see, I am also a 1st generation college student. You know, growing up back home, college wasn't really promoted for people like me or even kids in my neighborhood. We often go straight to the workforce after we graduate high school. I was planning on being a mechanic, actually. However, last minute, I decided, you know what, maybe this college thing could work out. I was lucky enough to take the right classes. So I sent an application to my first choice, UC Merced, and they took me right in. And I was, originally going to be like a high school dropout, but now we're going straight to graduate school. Let's do it. UC Davis, hit me up. My phone number is on my application. Next slide. Yeah, so in addition to the pandemic, we've also faced several hardships during my lab. I joined my group in early 2020, and we've been having a lot of adventures since then. In January, a water pipe burst above our lab and started raining on all of our equipment. So I had to chase my PI down and then interrupt a very important presentation to tell them, hey, there's water coming from the ceiling. So yeah, after we did damage control and cleaned up all and covered all the electronics with paper bags and plastic bags and things like that, before we left, the ceiling was falling apart, as you can see in the image there. Before we all, as we were escorted out by the campus police, I said, hey, Dustin, my PI, take a picture of me, because I know it's going to make a great story eventually. Oh, one thing I forgot to mention is on the previous slide, you saw an empty table there. That table is objectively not very interesting. However, it's been empty at least 3 times, and I've had to set up my experiment several times throughout the year. So what is that table for? Well, we'll talk about it right now in my experiment section. So the momentum of light is, or the speed of light is something that we know the value of. And we know that the speed of light decreases when it enters materials like water or glass. However, we don't yet quite know what happens to the momentum. This is because the absolute amount of momentum is very small and kind of hard to isolate from spurious outside effects. There have been a variety of theoretical and experimental evidence in favor of both theories, but the most prevalent have been by Abraham and Minkowski. Abraham argues that the momentum should decrease by a factor of index of refraction, whereas Minkowski argues that it should increase by a factor of index of refraction. So what gives us confidence that our experiment will give any definitive answer? Well, our experiment is measuring forces on the scale of nanonewtons. Nanonewtons are very small. Anything is super small. Watch, I'm gonna move 1 nanometer. You couldn't even tell, I just did it. So let's go more into the next slide. And this is where that image of an empty table becomes relevant. So I definitely, yes, here's a picture of our experiment. Starting here at number 1, we have a purple 405 nanometer laser that shoots a purple beam horizontally. It hits the mirrors at number 2, bounces off our water cavity at 3, bounces up, hits another mirror, and into our camera. This camera we're using is a very high-speed camera, and the pixels on it, 1 pixel is about 6.9 micrometers. At number 5 here, we have a green, powerful 1-watt laser that shoots a beam that comes straight down from the top. It hits the surface of our water pool perpendicularly. And the force that the green laser applies onto the surface of water will distort it a bit, and depending on the correct model of momentum, you should see the purple laser be displaced in one direction or another. So next slide. So yes, we use a variety of image analysis. Here on the right, now I got to refer to the script. Let's see. What you're seeing here on the right, that is actually a picture of a laser moving across our camera sensor. And this gives us our ability to measure forces on the scale of nanonewtons, because as I mentioned before, each pixel on that camera is about 6.9 micrometers. How do we use this image to find a momentum of light? Check out my video on GoReact. And while you're there, give it an A+. Next slide, please. Shout out to the people that have helped me along the way. The boss man, Dustin Kleckner, including my friends, Adrian Estrella, Christina Valletta, Andrea Collins-Head, and also a friend I forgot to include, Juliana Perez and Tomas Virgin. They're in the video, they're in the call right now. And David J. Griffiths, I gave him an email, I said it's okay to put his name on my presentation. That is it, peace out, y'all.
All right, thank you very, very much, Matthias. That's a great way to end our student presentations. I'm giving you all a virtual round of applause. Let's see if my co-host, Lolita, I don't know if you're able to stop my share screen because I happen to be frozen a little bit here. Let me know if you're able to do that.
I am not, unfortunately. Let me try something else. It will not allow me to stop sharing.
Okay. Oh, there we go. Now we have.
I did it.
Okay. Perfect.
Thank you.
All right, Rich. Well, now that I'm off screen share, then Rich, you can take the floor and you can do our next. Have any remarks on our last intro?
So first of all, thank you to all of our 9 speakers from each of the campuses: Jesus, Kia, Reza, Matias, Diana, Giovanni, Bernice, Natalia, and Jennifer. You all did terrific jobs. Thank you for sharing that. And I just want to encourage everybody to, look at each other's projects. Go react over the next few days. Go in there, as Matthias said, give everyone an A+. Be supportive. That's terrific. So we're near the end of the program, and we're going to close by some closing remarks by the actual principal investigator of this camp project. It is Kim Wilcox. Kim Wilcox is the 9th Chancellor of the University of California, Riverside. He joined us here in August 2013. He's extremely supportive of all projects. And the one thing I know about Kim is he's extremely supportive of students, student success. And so it's my honor to introduce Kim Wilcox. Kim. We may have to unmute Kim.
Yeah, I actually lost my capability here. Rich, would you be able to promote
I think I can
Kim
do that.
as a co-host?
Yes.
Got it.
Got it. All right.
Great.
You asked me to come and wouldn't let me talk.
Old trick I have.
Careful or diligent search. Careful or diligent search. That's Webster's definition of research. When I was in grade school, I thought of science as people with white coats and doing titration and Bunsen burners. That's just the trappings and the tactics. Research is about a careful or diligent search. And you all have now come to appreciate that, yeah, we're searching for answers, but the answers come after you come up with the questions. And then you set about as best you can to create a diligent search for the answer. Now, diligence means, yes, being careful with your reagents and being careful and precise with your measurements, but it also means being knowledgeable about the question you're asking. Just like any other search, you don't go off looking, if you're looking for mushrooms in the woods, you don't go where you think there aren't going to be mushrooms, you go where you think there are, based on your experience, based on what your parents told you about mushrooms, based on what you know about the geography, you know about the weather. The same is true in research. A diligent search starts with some knowledge. You then take the knowledge, apply it in a diligent and careful way, and hopefully, just like the mushroom search, you end up finding the answer to your question. And I know that's part of what your experience has been, this careful and deliberate search for an answer in your research areas. But I hope it's also been broader than that. I'm guessing many of you are thinking about graduate school, and you probably at one point said, I got to do some research on graduate school. Same thing, a careful and diligent search based on what you know about your own abilities, based on what you've learned, based on what you can find out about the graduate schools, who's on the faculty, how much are the stipends, important information in your search for the right graduate school. This notion of being careful and diligent doesn't just apply in the laboratory, I believe. It applies to so much of life. And I hope that the skills that you've learned here as part of the camp experience are the ones that you can transfer to all other parts of your life. And I didn't get a chance to listen to all the talks. I caught the last few. I know one lesson that you learned, which is crucial, and that's the reliance on colleagues. There are very few successful research programs that are totally independent. I don't know if I could think of even one. It takes not just the people around you in time, but all those people who came before you, who laid out the correct, what reagents to use, what measurements are, who invented the laser, right, Matthias? Somebody else helped all of us get to where we are. And I really appreciate the nature of the presentations and the clarity with which you recognized your colleagues. That's probably as important in the search for truth as anything, to recognize that you're not in this alone and that others helped you get there. And if it's true in science, Lord knows it's true in the rest of life as well. I'm looking at Juliana's daughter, is that right? Yeah. There are lots of people around us who make this journey not just pleasant, but meaningful. They're oftentimes in the laboratory, they're oftentimes in the classroom, but they're probably even more often at home or in your former home if it's mom and dad and you've left home and live on a boat, which I think is the first time I've had a camp student tell me they were living on a boat. So shout out there. I'm just really proud of the program. I'm proud of what Rich and all his colleagues have done to create this program. I'm proud of what you have accomplished. I like to say that universities are simply collections of people. We think of, the campus. You come to visit the campus when you're looking at which school you want to go to. If you're going to graduate school, you want to go visit the department. All that stuff is fine. The buildings, the labs, the equipment, all that's fine. But really what universities are collections of people. I say all the time, if we had the big earthquake here, all our buildings fell down at UCR, we'd still have a university because we would continue to go on and do our work in the lab, in the classroom. If that's the case, then a great university is simply a collection of great people with aspirations, with abilities, with dedication. And a great camp program is just the same. It's a collection of people who are dedicated to the same mission, making sure that the next generation of scientists and scholars is talented, prepared, diverse, engaged, and successful. And that's what you have become. Without you and your efforts, none of this would be possible. None of the successes of the program and none of the brighter future that lies before us. So I'm just really proud of you. And I know that all my colleague chancellors are proud of you. We're proud to call you colleagues in science and in education. And I wish you all the very best. Wish I could have been here for the whole meeting, but I'm glad I caught part of it. Now they want to mute Rich.
Oh.
They run a tight ship around here.
Yes, well, thank you, Chancellor Wilcox. Before I turn this over to Nee and Lolita for last minute instructions, I do want to once again congratulate all of you for your presentations and your participation. I also want to once again thank everyone, especially all the program coordinators, but especially Nee and Lolita for all their hard work to pull this off. It's not easy to pull off a symposium virtually. It's certainly not easy to do one with multiple parts, which are both synchronous and asynchronous, one that'll will last just about a week. And I just want to remind you, although I'm sure Nee and Lolita we will reconvene virtually next Thursday at 7 o'clock. One small request, if I can, you all received one of these camp backgrounds that Christian Noble created for us. I think it would be really terrific if on Thursday we all had some background. I think it would make an amazing picture and screenshot that we can then send to NSF, right? So I hope you will join us. And again, thanks. I'm going to turn it back over to Nee and Lolita.
All right, thank you very much. So I'm having a little bit of technical difficulties on my end in terms of screen share. So Lolita will be taking the lead. Thank you very much. And we have our last set of slides. So Lolita, this is actually all you.
All right, thank you so much. I hope you enjoyed the presentations. I just wanted to point out that the presentations are not over. I wanted to say, but wait, there's more. You can view pre-recorded videos on GoReact anytime this weekend. And we hope that you will do that. You can view the videos and also make comments on the presentations. We hope that you leave lots and lots of comments, and we have incentives, especially for all of the presenters to do so. Again, you can go in at any time on GoReact. We will drop the link to register for GoReact in the chat, and pre-registration is required for that. So we hope you will join us over there and have an opportunity to hear all of the presentations. And I also want to bring your attention to a kudo board. Again, a lot of people said this is a community, and we're hoping that you will join us in congratulating our presenters. Feel free to use the kudo board to either put up pictures, leave comments to our presenters to encourage them as well. We'll also drop that link in the chat for you. And I do want to give a shout out to UC Berkeley, to Di and Chris also for creating this wonderful kudo board. But wait, there's more. Just in case you were wondering, that is sort of a UC Davis inside joke. All of the students know about this very well, as it's something that we use to be able to communicate our research, to share more information. So there is an awards ceremony, and you are all invited to that as well. It will be Thursday, February 18th from 7 to 8 p.m. And for everyone who registered for this conference, we have your email information. We will share that link with you as well. So the awards that students could receive for presenting, there's Special Merit Award as well as an honorable mention. We also have special VIP awards. This is very important participant award, and you can leave comments. So the participants of this conference can leave comments on others' presentations. We're able to track that information and to see the comments, etc. So the student who's very busy can also win an award. We also have the Best Video Award. So again, we encourage you to also make comments. If you think it's a Best Video Award, be sure to note that too. So that concludes it for today. We want to thank you for your time. And at this time, I will turn it back over to Dr. Cardillo.
Well, again, that's it. Please visit each other's presentations over the next few days. Encourage each other. Make sure that you have arranged your meetings with your faculty judges. I'm also in contact with them. I'm available all through this long weekend. So again, thank you. I guess the last thing I want to say, and I think you probably already know this, University of California as a system is just amazing. It really, truly is one university, 10 campuses, 9 of which happen to have undergraduates on them. You truly are amazing. And in a very real way, each and every one of you is fulfilling the primary mission of the University of California, which is being engaged in research. So I want to congratulate you on doing that as well. And we will see you next Thursday. Take care, everybody.
Don't visit Go